Hi, this video will cover section 1.2, slope formula and graphing linear equations in slope-intercept form. And this is for the class Math 0305, which is a co-requisite with the class Math 1324. So we're going to go over the definition of slope in an algebra way. So we have here that the slope of a line that passes through 2 points is defined as the change in y divided by the change in x. Also, it is also known as the rise over run. And with that said, please remember that the difference, well, the way we calculate the rise is by getting the change between the y values, and the way we calculate the run is by getting the difference between the x values. So always make sure that you're conscious to put the y values on the numerator, the difference of them, and the difference of the x values on the denominator. So in this case, if the number that we obtain for the top, for the rise, is going to be positive, then we will move up. And if it is negative, we will move down. Now, for the run, if the sign that we get on the bottom is positive, that means that we will move to the right. And if it is negative, we will move to the left. So now that we have that, one of the things that I strongly recommend is that you always use your slope, the formula, so that you can memorize it. And even if you have it there, you write it down before you start substituting. Now, what we're going to do is we're going to calculate the slope. But we're going to do that graphically just by looking at our points and counting the spaces. So we're going to go, the key here is to select 2 points where you could see clearly what the coordinates are. So for example, this one on the y-axis, which we also refer to as a y-intercept, has the coordinates of 0, -2. And if we look at, let's say, this point right here, I think that's a very good one. It does have the coordinates 4, +4. So 4 for the x, 4 for the y. Now, if I want to count the spaces from this point on the bottom to the point on the top, I would start by counting 1, 2, 3, 4, 5, 6, 7. So we already established that the slope is the rise over run. And so in this case, we will have, since we went up, we will have +7. And now we count our spaces to the right. And so that will be starting from here, 1, 2, 3, 4. And we move to the right. And so because of that, we will have +4. Now let's move on to the next one. And again, we're going to find them by counting. And so here, keep in mind that the y-axis is here. And the x-axis is here. So the window, your viewing window, is a little different than what we're used to. So here's the origin. And so we're going to select 2 points again. I would like to select this one here. So the coordinates for that one, well, I guess it doesn't even matter because we're just counting. Let's select this one here as well. Okay, so now let's count. So I'm going to go from this point right here to the one on the right side. So I'm going to count the spaces that I have to go down. 1, start here. So it's 1, 2, 3, 4. Actually, I went 1 too far. So it's only 1, 2, 3, 4. So we stop right here. And now we move to the right, starting from here. So 1, 2, 3, 4, 5, 6. So we went 4 units down, and we move 6 units to the right. And so that will be -4 over +6. And remember, the letter that we use is M for slope. I'm going to just double check. Okay, so it seems like it's not. Okay, so let's try to check our work numerically. So the first point that I chose, the one here, it has the coordinates of -2, comma, -5. Now my point here, it does have the coordinates +4, comma, -8. And so if I apply the formula for slope, we will need y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so here, let's use -8 as our y sub 2. Then we need a minus, and we have a -5 for the y sub 1 over x sub 2, which is going to be 4 from here. And then minus, and we have a -2 for our x sub 1, which is here. So we do have some double negatives. And with that, we're going to have to substitute or clear the negatives. So negative multiplied by a negative will be positive. So we have a plus 5 over, need more space here, over 4 plus 2. And so that will be -8 plus 5 will be -3. And 4 plus 2, it is 6. So yes, I had made a huge mistake here. It is not 4 down, it was actually 3. So it was from here, 1, 2, and 3. So my bad, we had to go 3 units down only. So you see, this is a very nice way to double check your work. You could check it graphically, and you could also check it numerically with the formula. So let's move on to our next problem. To our next page. And so for this one, our line happens to be horizontal. And you could see it. It's going here across y equals -1. Now, I can tell you right now that because this is a horizontal line, the slope of any horizontal line is equal to 0, but let's see why. So I'm going to choose 2 points. I like to use 0, 0 a lot because it makes things a lot easier. Let's try to choose this one here. And actually, it's not 0, 0. My mistake. It should actually be -1 for our y value. And for this other point, we're going to give it the coordinates 4, comma, -1. So now I'm going to use the formula for the slope. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's see what we get. So for y sub 2, we have a -1, then minus, and now we have a -1 as well, because the y is something that they do have in common. If you notice here, both points have the same y value. Now, if we keep working this problem, we'll have divided by, and x sub 2 is a 4 minus x sub 1, which is a 0. Now, from here, we take care of this double negative situation. So we'll have negative 1 plus 1. And on the bottom, we'll have 4 minus 0. And so in this case, negative 1 plus 1 is 0, and the bottom is 4. Now, any number that is 0 divided by any number is equal to 0. And so that is what I told you before. The slope of a horizontal line is 0. Now, let's go ahead and move on to see what will happen with our next problem here. And so in this case, we do have, need to find it first. So let's just make sure we know where we are. So right here, this one is the y-axis, okay? And this one is the x-axis. There we go. So the line that we are supposed to find the equation for, it will be this one here. So this line happens to be a vertical line. And let's go ahead and pick 2 points. One here, one here. Let's see. So the coordinates of this point that I picked on top are going to be -3, 1, because this is a 1 and this is a 2 for the y's. And then for my other point, the coordinates will be -3 for the x. And now for the y, we will have a -2. Now, let's go ahead and use the slope formula. So we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so that will be equal to, I'm going to take -2 minus 1 over -3 minus, and then -3 in parentheses. So from here, you already know that we need to take care of that double negative. So this will be -3 plus 3. So to keep simplifying this, -2 minus 1 is -3. And now to simplify this denominator part, -3 plus 3 is 0. Now, anytime you have a number, any number divided by 0, it will be the undefined. So what I need you to remember from here is that any horizontal line the slope is going to equal to 0. And for any vertical line, the slope is undefined. Now, another concept too that we need to cover will be the slope-intercept form of a line. So stepping away from horizontal and vertical lines. And so right here, the letter M, again, stands for slope. And we use the letter M because it comes from a French word that has something to do with mountains. That's why. Now the B, we're going to use that as our y-intercept. So imagine if I was to substitute my x here with a 0. You know that anytime the x is 0 for a point, that means that is going to be on the y-intercept. So if the x was 0, this will cancel, will go to 0, so we would just have y equals b. In other words, if x is 0, y equals b, and that gives us a y-intercept of, as a point, we will write it as 0, b. So now for example 2, they want us to use the same graphs from example 1 and find the respective equations. So let's go back to example 1. example 1a, I should say. And so for that one, we got a slope of 3/2. And I actually made a mistake and I deleted everything here. Right here. So we had that our slope was positive 3/2. And if you notice here, the y-intercept, it happens to be -2. So then as a point, the y-intercept will be 0, -2. And so with that said, we could create the equation, substitute m and b. And so instead of m, we will write the slope positive 3/2 x -2. Why is it -2? Because that is the value for b. You could also see it here. The y-intercept has the coordinates 0, -2. And so this is the answer to that question. Now for example 1b, we had a slope. I don't even remember what we got for that slope. So let's just double check. Okay, so this was the one. Let's see if we just count from here to here. Let's see. We will go down 2. And then we will move to the right 1, 2, 3, 4. So positive 4. So if it was wrong in the other video, please correct it. I don't even remember what I had. So -2 over 4. And we could reduce that fraction to -1/2. So now we already know the y-intercept is right here. And that happens to be 0, -6. Why is it -6? Well, because this is -5. So that's -6, -7, -8, -9, -10. So with that said, that will give us the number that represents b, -6. So then the answer to this question, the equation of the line, will be -1/2 times x minus 6. And we can go ahead and write that down here. Y is equal to -1/2 x minus 6. And that will be the answer for that particular question. Now, since our next two, we had one that was a horizontal line, and we say that the slope for that one, for the horizontal line, for 1c, the slope is equal to 0 by default. If it's a horizontal line, the slope must be 0. So the horizontal lines, if we were to create a table of values, it doesn't matter what we choose for x, the y will always be the same number. And I believe in this case we got, I'm just going to verify, it was a -1 right here. So this was, the equation will be -1. Why? Well, because it doesn't matter what your x values are, the y value will always be -1. And so, yes, we say the equation is -1, which is the only y value that repeats. Now, once we move to example 1D, we were dealing with a vertical line, and that vertical line was actually right here. at x equals -3. We already know the slope is undefined, so we don't even need to use any formula. All we can say is x equals -3. If we were to create a table of values, it doesn't matter what the y value is, the x value will always be -3. And so because of that, the equation is -3. So let's write that down. So this was y equals -1, and here we have x equals -3. So then let's go ahead and cover the last concept from here. So we're going to be using the equation to plot the points. So the first thing we're going to do is plot the y-intercept, and then we're going to use the concept of the slope, the rise over run, to plot a second point. Once we have 2 points, we can connect them. And this is the same way you could do your homework on my math lab. So first graph here, we have that the y-intercept has the coordinates 0, -4. So I'm going to start by plotting that point. And then I'm going to use the fact that the slope is +3. So that means 3/1 because it's an integer. So I could say I'm going to move 3 units up and 1 unit to the right from this y-intercept. So 3 units up, 1, 2, 3, and 1 to the right. So right there. I can do that again. 1, 2, 3, 1 to the right. And after that, I need to connect my points. Of course, this is not very straight, but just imagine that it is. Let me see if I can make it better. Oh, maybe. There we go. That looks a little better. So that will be the equation of that line. Now let's move to the next one. And for this one, we have that the y-intercept is going to be the point 0, -1. That's our y-intercept. So let's go ahead and plot the point right here. And then our slope is -2/3, so we can go 2 down and 3 to the right. So we will move 2 units down and 3 to the right. Then again, 2 down, 3 to the right. Remember what we discussed in class? We could also have +2 over -3, and that will tell us 2 up and 3 to the left. So I'm going to do that again from the y-intercept, and you will see that the points will still be on the same line. So I'm going to move 2 units up and then 3 to the left. 1, 2, 3, right there. And so I can connect those points, and of course I get another line. Now let's move on to our last page from the section. So remember, y equals to a number that refers to a horizontal line, and x equals to a number, it refers to a vertical line. So if it says x equals 2, then I want to plot points everywhere where the x is equal to 2. And so if I connect all those points, I will be able to get that graph. For my horizontal line, I will do something similar, but now I want all my y values to be 4. And of course, if I keep plotting points and I connect them, I will get my horizontal line. And I believe that is the end of the video. Thank you for watching.